Hello everyone. I managed to replicate Stan Meyer's waveform with my cell made of nickel plated copper. The outer tube is black, looks black, and as you can see on the voltmeter it reaches 1.43 volts now. It behaves a little bit like a battery. The black stuff is nickel hydroxide. The electrolyte, the solution is sodium hydroxide, about 5%. I will explain the setup later. I will first switch it on and see the gas production. It draws about 580 milliamps now, and it does produce a reasonable amount of gas. Alright, I'll zoom out now and switch to the zoom into the oscilloscope. Alright, this looks reasonable now. So this is the waveform Stan Meyer used. The voltage across the cell has now increased to 1.96 volts, and it draws around 550 milliamps, and the power supply reads about 3.5 volts, but it's probably somewhere between 3 and 5 volts. Alright. Okay, this one doesn't want to trigger. I don't know why. I can't get this stable for some reason. This one does. So there is a hotspot. It does produce a reasonable amount of gas, very tiny bubbles. And this is the waveform closely. So there is a hotspot. If I turn the frequency on the PLL circuit from David Lawton, you can see the if I turn it lower, well, the waveform it just decreases, and here's the hotspot, and if I turn it higher it also goes down. So I'm going to tune it to the hotspot. Right here, something like that. Alright, now I'll zoom out a bit. Hopefully you can read the amperage meter. So I can adjust the voltage. If I turn it up, the amperage increases very rapidly down so as 1 amp, and then it produces a lot more gas. And I also can with this. This is, well, maybe this is about 5-6 volts or something. If I decrease the voltage, then the current drawing also drops pretty rapidly. And at 10 volts I already draw 2 amps. About 500 milliamps seems to be reasonable. I will zoom into the scope once more. I'll turn on the intensity and hopefully you can see the spikes. I don't know if that is visible. So on top of the waveform there are also spikes all the way up to the top of the screen. Okay, now the circuit, I use a standard, let's zoom out first. So the circuit, I use a standard Dave Lawton PLL circuit. I made a little modification. I'm using a tip 122 bipolar junction transistor, because I kept on frying my MOSFETs. I didn't like that pretty much. So inside I I removed resistor number 10, I think, and it changed the value of resistor 9 to 1K. And here I have a toroid. It's wound with the wires I got from Cortis Town. I don't know how many turns, but it's a bifilar wound coil. It's wired. This one is the plus connection, and this one is the negative. So they are bifilar wound. The other side, the plus connection, goes to the cell, as goes the negative connection, and this negative connection is switched by the transistor. And now here's the little secret. I added a diode, and it goes from the negative connection to the coil, so basically from the collector of the transistor, and it goes into the positive connection of the cell. So basically I'm dumping the back EMF from the negative coil onto the positive cell, and then suddenly you get this ringing effect, and yeah, there's some kind of oscillation. And well, depends on how much gas you want to produce, but now like 500 milliamps, I do have a reasonable amount of gas production for such a small cell. It's two pieces of copper tube. I think there's like 7 centimeters long or something. So that's what I wanted to show for now. Yes, the schematic I used, basically the same as Dave Lawton, only I added an extra diode from the collector of the transistor to the positive of the fuel cell.